Bismillahirrahmanirrahim. A parachutist is falling through air at terminal velocity. Terminal velocity का मतलब है हमारे पास acceleration zero है, our velocity is constant, and our F net is zero. These are the three things that should come into your mind whenever you hear the word terminal velocity. Now, which statement is about the parachutist is correct? Every force acting on the parachutist is equal to zero and its acceleration is equal to zero. This part is correct. However, all the forces acting on the parachutist is not equal to zero. Their net, F net, your resultant force is equal to zero, not the forces itself. So the forces cancel each other out. So A is not the answer. Every force acting on the parachutist is equal to zero and its velocity is equal to zero. This part is wrong. This part is also wrong. C. The resultant force acting on the parachutist is equal to zero. Okay, this part is correct. And its acceleration is also equal to zero. So your answer is going to be C. The resultant force is equal to zero, and then your acceleration is also equal to zero. And then we can also check part D. The resultant force acting on the parachutist is equal to zero, and velocity is equal to zero. This part of the question is wrong. Okay, so your answer C. Question number two. The curved line on the graph shows the motion of a car. What is the acceleration of the car at 4 seconds? At this point, what is the acceleration? Walaikum assalam. Over. So we just have to find the gradient. Gradient is equal to y2 minus y1 over x2 minus x1. You just substitute in the values. The easiest thing you can do is you can just take this 4, 9. This is 1 point, and you can take this. This is 2, 3. We just have to substitute the values 9 minus 3 over 4 minus 2. So the answer is going to be 6 over 2, and the acceleration is 3 meters per second square. Now, why did I take the gradient? Why did I find the gradient? The question says it's find the acceleration. It's a speed time graph. So, okay, it's a VT graph. Yeah, we can write it, it's an ST graph, speed time graph. So the gradient of a speed time graph is equal to your acceleration. We all know that. Easy peasy lemon squeezy. Question number three. The diagram shows a bird in flight. The bird is flying in a horizontal direction to the right. So the direction of the bird is to the right. In which direction does the air resistance act on the bird? In which direction does it act? We all know that air resistance always, and I repeat, always acts in the opposite direction to motion. So if it's moving towards the right, the direction of the air resistance will be towards what? Towards the left. Okay. Question number four. Which graph represents an object that is moving at a constant speed? At a constant speed. So for it to move at a constant speed, all of these graphs are distance time graph. For it to move at a constant speed, we need that the gradient of this graph, gradient, gradient should be constant. So what should be the answer? A, B, C, D. Remember, the gradient over here is zero. I know it is constant, but it is zero. So A cannot be your answer. B and C are not straight lines, so the answer is clearly D. Easy peasy lemon squeezy. See, the gradient of the straight line M is constant. Again, this sign represents constant. Question number five. An object is moving with uniform deceleration. So your acceleration is negative something, okay? Which statement describes its motion? So it's uniform deceleration. So your acceleration is constant. However, it has a negative sign with it. You guys, I'm pretty sure you guys understand what uniform deceleration. Uniform means constant, okay? If anyone is confused. So which statement describes its motion? Its rate of change of speed. Rate of change of speed क्या होता है? It is your acceleration. So its acceleration is decreasing. No, the acceleration is constant. Its speed is decreasing. Constant. Nope. This is also not correct because we have negative acceleration. Its speed is decreasing. So your answer is gonna be C. And again, D cannot be the answer. Its speed is increasing. How can it increase when the object is decelerating? So the answer is C. Easy peasy lemon squeezy. Question number six. The graph shows how the speed of a car varies during the part of its journey. What is the value of the car's acceleration between 6 seconds and 10 seconds? So we just need to find the gradient. So y is equal to m2 minus m is equal to y2 minus y1 over x2 minus x1. We'll take the values. We always write the x variant first. So it's going to be 10 and it's going to be 15. And over here it's going to be 6 and 10. Find the gradient and just give me a minute, okay? What's the answer? 1.25. So we'll just substitute the values. Again, 15 minus 10 over 10 minus 6. It's very simple. You just substitute these values. You take these, you subtract both of these, and you subtract both of these. These are the x coordinates, these are the y coordinates. You all know that, right? I'm pretty sure you do. So it's going to be 5 over 4, which is 1.25. So your answer is going to be C. Easy. Question number 7. The gravitational field on the moon is less than on the Earth. Which of these is different when done on the moon compared with when done on the Earth? Give it a try. Which of these is different when done on the moon compared to when done on the Earth? The gravitational potential energy gained by the stone lifted through the same vertical height. The kinetic energy gained by a ball when hit with the same force for the same period of time. No, this cannot be different. But this is going to be the same, okay? The momentum gained by a bullet when fired from the same gun, same. The work done in accelerating a stone from rest to the same speed, same. So, guys, the only thing that's going to be different is going to be A. Now, why did I still read all of those? Because whenever the answer is A, all of those will be wrong, but we still have to know why they're wrong. So, A is the answer. I'm going to explain that mathematically. So, your gravitational potential energy is equal to mgh, right? mgh. Now, if it's equal to mgh and the value of g is considerably less, it says here that where the gravitational field strength on moon is less. So g is less. Actually, it's around 3.6 if I'm not wrong, 3.7. So if you compare that to 9.8, there's a significant difference, of course. So if your g decreases and your height remains the same and your m also remains the same, your gravitational potential energy in fact will decrease relatively. We're talking here relatively, okay? So A is the answer and all others are correct, okay? Another, I would say the way you could have done this question is B, this statement, the kinetic energy gained by a ball when hit with the same force for the same period of time. This is a pretty, if I'm being honest, a complicated statement. And in O levels, usually such complicated statements are never the answer. However, ये आपने सोच के कोई आंसर लेना नहीं है, but जब when I read this, I knew B could not be the answer. As a teacher, आपको पता होता है कि इतनी मुश्किल चीज़ नहीं देते वो O levels में, ठीक है? But still, has nothing to do with you guys. You should know the answer. And A, you could also prove it mathematically. Okay. A box of mass 2 kg is pulled across the floor by a force of 6 Newton. So it's a 2 kg box and we are applying a 6 Newton force on it. The frictional force acting on the box is 1 Newton. What is the acceleration of the box? So F net is equal to ma, right? So F net is your resultant force. So 6 and 1. So F net, 6 is towards the right, 1 is towards the left. What do we do? Do we add them or do we subtract them? They're acting in the opposite directions. We subtract them, right? So it's going to be 6 minus 1 is equal to m, which is 2 into a, which is your acceleration. So the answer to this question is going to be 5 is equal to 2a, and a is equal to 2.5 meters per second square. Easy peasy lemon squeezy. Is this clear, everyone? Is this clear? Easy peasy. Question number 9. Which moving body has a resultant force acting on it? Whenever you get a question like this, you'll find a lot of questions following the same pattern. Okay, the answer is always, I'm not going to read these, but I know that the answer is always going to be something traveling in a circle. So what could be the answer? A driver rising vertically through water at constant speed. If something is at constant speed, f net is 0. That means no acceleration. Constant speed, I do not even need to read the question. A, and terminal velocity, again f net is equal to 0 and acceleration is also equal to 0. So the answer is going to be an aircraft circling an airport at constant speed. If you look at this constant speed, again your f net is 0 and your what do you call, your acceleration is also 0. However, for it to travel in a circle, it needs centripetal force. So it has force, but the force is acting perpendicular to the velocity. I taught you in the last class. I believe we had our last class on Monday, right? I taught you that whenever we get this, whenever you have an object traveling in a circle, there is a centripetal force acting towards the center, and then you also have a velocity that acts at a 90-degree angle. Do you all remember this? Now, do you guys want some fun facts for better understanding? For better understanding, always remember this is just extra stuff, okay? I'm teaching you guys. This F net and this 90 degree, sorry, this velocity is at a 90-degree angle. So this force has no effect on this velocity. Remember, and I want you guys to note this down if you want. Like, when I was in my O levels, what I used to do, I used to write NB. NB stands for Noto Biane. I don't know what language that is, or if even if that's English, but it stands for Noto Biane, and it means something important. Okay, our teacher taught this when I was very young, so I'm still use this. So write this whenever two forces are at a 90-degree angle. Whenever two things, you can just write two things are 90 degrees angle, they do not affect each other. These two things have no effect on each other. So this force does not affect the velocity at all. Do you guys get that? So see, that's why it has a constant speed. The speed remains constant. However, there still is force. Is that clear? Interesting stuff, right? Question number 10. The velocity of an object increases from 30 meters per second to 50 meters per second in only 5 seconds. What is the average acceleration of the object? So your acceleration is v minus u over t. So it increases from 30 to 50. So this is your initial, this is going to be u, this is your final, and this is going to be v. So 50 minus 30 over 5. So the answer is going to be 20 over 5, which is 4 meters per second square. Easy peasy lemon squeezy. Okay. Question number 11. Okay, I'm gonna end one recording here.